Okay, we're going to look into present value using compound interest. So our formula is the same. A still is total amount, P is still the principal, I is still a formula of the interest rate divided by compound period, and N as the number of periods is years times compound period. So just relook at, if you guys don't recall how to solve those, relook at future value of using compound interest. So let's say there's a bank and we want to invest money to get $1 million in 25 years. Okay? In 25 years, I want to have $1 million in the bank. The bank, because they know I'm going to have to invest probably a large amount, they're willing to be pretty generous, and they're going to give us 3% annually. But it's going to be compounded again. This time they're going to compound it a little differently. We're going to say they're going to compound it weekly. That's very nice of them, because most banks wouldn't do that. So compounded weekly. Weekly compound. We're going to be writing the exact same formula and plugging this stuff in, but there's a big difference. This time, $1 million isn't the principal. The principal, or the amount of money we're going to put in the bank, is the stuff we don't know. So we're going to calculate how much money we need to put into bank right now, so that in 25 years, we'll have $1 million. So that means our A, or our total amount, is the $1 million. So A equals P, 1 plus I, power of N. So our A is $1 million, which is equal to the principal, which is unknown. 1 plus I is our interest rate divided by compound period. Well, R is our interest rate, which is 3% as a decimal, 0.03. So 0.03 divided by compound period. How many weeks in a year? 52. So it's divided by 52. That also means, though, for 25 years, our N is years times compound period. So our years, there's 25 years times how many compound periods a year? 52. We're going to have a very large exponent. So I'm going to move this over a little. What if it's a leap year? Still same amount of weeks. Doesn't change. Okay? Principal times, let's figure out 0.3 or 0.03 divided by 52. Okay. That's moving the decimal place 4 spaces over. So there are 3 zeros in front of that number. 1, 2, 3, 5, 7, 6, 9. Roughly. Okay? Oops, and that has to be plus 1. Can't forget that. Isn't that nice? I don't have to erase anything. 1 plus that. And then our compound period is 25 times 52. 1,300? Right on, okay. So to the power of 1,300. We're going to calculate that number. So we still have 1 million. One plus that is just going to be 1.0005769 to the power of 1,300. So to be extremely accurate, I keep that number in my calculator. Oh, I lost it. We're going to get it again. 0.03 divided by 52. Okay. We're going to add 1 plus 1. Here's our value, which is pretty much what we've written here. And I'm going to put it to the power of 1,300. Okay. 2.1165. So P times 2.1165. How do I isolate P? Yeah, we can do that, but we also could just divide. Divide 2.1165 on each side. So we're going to take our million and divide it by 2.1165, which is going to tell us our principal. So the amount of money we need to invest now. So we take 1 million, 2, 3, 4, 5, 6, divided by 2.1165. And apparently I need to invest 472, 478, 14. 472, 478, 14. So we need to invest $478.14 right now at a rate of 3% annually, compounded weekly, so that in 25 years we'll have $1 million. Okay? It's not bad. This could be done.
But if you take out that $1 million, then you get taxed on it.